Hey everyone, today we're going to take a look at week 7, lesson 2. This lesson is our introduction into square roots and perfect squares. So I want to start, rather than diving into the example problems, by taking a few notes. We've been working with exponents. So we know that 1 squared is really 1 times 1, which is 1. And then we can do 2 squared, which is 2 times 2, which is 4. 3 squared is 3 times 3, which is 9. 4 squared is 4 times 4, which is 16. 5 squared is 5 times 5, which is 25. 6 squared is 6 times 6, which is 36. 7 squared is 7 times 7, which is 49. 8 squared is 8 times 8, which is 64. 9 squared is 9 times 9, which is 81. And 10 squared is 10 times 10, which equals 100. And what we're going to learn about this column right here is that all of these are perfect squares. And so we have a new symbol that we're learning about, which is the square root sign. And the square root sign looks like a division sign, but with a little added segment right there. And that is the square root sign. And just like the opposite of multiply is divide, and that the opposite of add is subtract, the opposite of squaring something is taking the square root. So they work exactly like an inverse operation. So that means if I wanted to find out what the square root of 1 is, it means what number multiplied by itself twice would give me 1. Well, my answer would be 1. And if I wanted to know what the square root of 4 is, what number multiplied by itself will give me 4 is 2. If I wanted to know what the square root of 9 is, what number multiplied by itself twice would give me 9 would be 3. And then we can see a pattern between 1 squared is 1, well, the square root of 1 is 1. 2 squared is 4, the square root of 4 is 2. 3 squared is 9, the square root of 9 is 3. They're inverse operations. So then we can follow that exact same pattern where the square root of 16 is 4, the square root of 25 is 5, the square root of 36 is 6, the square root of 49 is 7, the square root of 64 is 8, the square root of 81 is 9, and the square root of 100 is 10. And so in this introductory lesson, all we need to know that these are all perfect squares, and that taking the square root of something is the exact opposite of squaring it. So if we look at the packet or the worksheet that was assigned for week 7, lesson 2, we can solve a couple of these pretty easily. If we just start with number 1, number 1 is just saying, well, what is the square root of 100? Well, what number multiplied by itself twice would give us 100? Well, we can use this now cheat sheet that we've created to know that the square root of 100 is 10. And so our answer option for number 1 on our worksheet would be letter D. That says our answer is 10. Numbers 1 through 10 All it's asking you is to identify the perfect squares. And then when you look at numbers 11 through 20, it starts to set things up as equations. And so if we take a look at number 11 on the worksheet, it gives us an equation with our radicals that says 7 equals the square root of k. So what does k equal? Well, if we look at this, they gave us 7, and we want to know what would be in the radical. So I can go back up to my cheat sheet and look for the number 7. And what is in the radical? It is 49. So our answer here would be 49. And if you're following along on the worksheet, that would be answer option A. And that works out because the square root of 49 equals 7. And then we can jump ahead and maybe look at number 20 together. Number 20 says the square root of b equals 1. Once again, we can use our notes that we just created and look for the number 1, which is up here. Well, when my final answer is 1, what needs to be under the radical is 1. And if you're following along on the packet, that would be answer option B, because the square root of 1 is 1.